Today, I want to show you 3 different ways how data can be difficult and what you can do about it. So those are the 3 ways: non-Latin characters in your data, non-ISO date formats, and the situations when the data that you need is not even in the database. And these 3 issues are so common that you are guaranteed to run into them. A little while ago, I filmed a story where all of these things happen and then they get solved. And today I will be using that story, except that here I will be explaining how exactly this is solved. Here's the snapshot of the story, and what happens there is this. One day, a queen stays in this hotel. A queen is a cat used for breeding. So after staying there, later she has a litter of kittens, and one of the kittens has a wrong color. So the suspicion is that some other cat got involved while she was at that hotel. So now people who work at the hotel need to find out which cat this could have been. This is the owner of the cat hotel. This is the data engineer who digs through the data, and later she also involves an intern data analyst. They use SQLite and the terminal to solve the problem. That's definitely not the tools that you are going to use, but that just shows you that if they can do it, then you can do it too. So first of all, let's see what they do. Here, you can see that they create a script file and then open it. Script is basically just a plain text file which you run instead of simply typing commands in a terminal. You can create a script very simply with the tools that you already have, even with a built-in Mac text editor. So just go to text edit application, create new document, and there you go. Just make sure that it's plain text. I think by default text edit has rich text, and that looks like this. This doesn't do it. It has formatting and markdown. You need to convert this to plain text like that, and then here you can write your commands, then you save it, and then you run it. But I will do it all from the terminal because that's how it happens in the story. So I'm not going to save this. Let me show you now how these commands work. So here's my terminal and here's my finder. Let's check where we are first of all. So print working directory. And that's our working directory under my name in users, which means we are right here. So everything we will do here, the files that we create, will appear here. And to create a file, there's this very cute command, touch. So touch space and then the name of our file. So let's do script and the extension. Now it doesn't have to be .sql, it can be txt, it can be whatever, as long as there's some kind of extension for it to work. Let's do it the standard way. And when I execute that, watch here how the file appears. So let's execute, and here's our script. We could double click on it now, but let's also open it with a terminal. Open, and then the name of the file, and I will use tab for autocomplete, and then -T to tell it to open it with the default text editor. Let's execute, and we got the same default Mac OS text editor. And here we write our commands. Let's see what's next in the story. Okay, opening the data file and then running the first script. Okay, let's start with the opening of the data file. Okay, so let me just tidy up here. Our data file is this one, and it's already in our working directory, so we don't need to tell SQLite a path where it needs to find it because it's right here. So it's going to be simple. Command SQLite 3 space and then our data file, autocomplete, enter, and that's it. We are in the database now. I'll just show you the difference writing straight in the terminal versus writing in a separate script. So let's say in all the previous videos we did it on the terminal, so this is how I would do it. I would select everything from, and in this case I know the name of the table. There you go, and that's how I would do it in the terminal, but I can do exactly the same thing here. Select from humans. And now I need to save it and then run from here. Running is done with the command read because SQLite reads this file and then runs it. So read script SQL. And you see here, it does exactly the same thing. So this command did that. That's the output. And then this read from this file, which is exactly the same command, and of course got the same output. And of course it's much more convenient to write SQL in a separate script because here it doesn't disappear. Of course here I can bring up the previous command like that, but it gets very fiddly when you are evolving the same query, which is typically what you do when you need a bigger SQL query. You start by writing a small piece of it, you execute, you check the output, and then you add a little bit to it and so on. So you're evolving it, you're growing your query. And that's much more convenient when you have it right here in the file and you can just go and change certain bits, like for example here, I can just change it like that. Say I want ID and name only, I don't want any phone numbers or emails. So that's all I do. I save it and then I rerun it like that. And there you go. By the way, let's also change the mode to something nicer. And let's rerun it. And there. And here we can already see what's our upcoming difficulty with getting the right data, because we need this person, but this person has really strange letters in his name. Now, of course, this is a data set that was created just for filming that one story. It only has 5 entries, but in reality, you would have hundreds or thousands or more entries, and you would have to find specific rows in it. So, of course, you wouldn't be able to list everything and just read through everything. You would have to use the where clause and use conditions. And in situations like this, you would have to use the like operator. Let me see how they do it in the story. So that's the first attempt at the query. Simply to, oh no, wait. Here's the first attempt, which doesn't work. And then here's the second. And then there's how it evolves. Okay, I will simply explain quickly everything you need to know and everything that is enough to know about this like operator and how it works to find what you need in 99% of cases. Okay. So what you really need to know and what is enough to know is these two things. First of all, the percent. And then maybe sometimes the underscore, but not so frequently. What percent means is any number of any characters. So for example, if I run this, actually then I should get all results because all of these names satisfy this criteria. Let's try that. Yes. Now let's narrow this down a little bit. Say will. Yes, and now I got only 2 results, those that do satisfy this criteria. And what I asked here is for will, even if and there can be anything before will and anything after will. So here we have exactly that. We're basically looking for this fragment. Now the second possibility besides the percentage sign is an underscore. It looks like this, and it represents exactly one character. So there can be any character in the place of an underscore, but exactly one, or as many as there are underscores. For example, let's try to find all names that start with W and end with an aim and then have exactly 3 letters in them. That would look like that, 3 underscores. And there you go. Now names with 4 letters, that's those, and so on. And that pretty much covers the like operator. I'll just mention one thing: case sensitivity is something to look out for. In our case, this is not case sensitive, but that's the thing with SQLite, and different flavor of SQL or your database will have a different opinion about this. But just to prove that, I exchanged this for a small lowercase w, and I still get the same result. But make sure whether you are dealing with case sensitive or case insensitive scenario in your case. And now we can move on to our second common issue: strange date formats. Here, this is what I'm talking about. And what was the query for that? I think it's select everything from stays, where human ID 62. Yes. Let me limit the results to make this nicer. Like that. There we go. So ISO date format would look like this. There would be a 4-digit year like this, a dash, then month number, and then date number. That's ISO. That's nice. And even though SQLite doesn't have this data type, which is date, yes, there is no date type in SQLite, but it can still deal with ISO even when it's just text format. It reads it and it understands it, and then it can compare. It can find something before that date or after or between the dates, and so on and so forth. But here we have a completely different format, and then SQLite also can't read it. It can cause issues in other databases as well. On top of that, you also have situations with timestamps, time zones, and so on and so forth. So you do need to know how to deal with that. The way I dealt with it, I asked ChatGPT, and now what I needed was something quite complex. So I needed to find records with an overlapping date range. So the record that I was looking for, more than one record, had to have the ending date later than the from date, but then the starting date earlier than the ending date of this range. So that required a fairly complex condition, and on top of that I had to parse dates from this text into a date. There is a date in SQLite, but there is no possibility to store data as date, right? But you can do date operations. So, and on top of that, parsing is not so simple because sometimes these digits are only single digits and sometimes double, which makes it harder. So the condition that I needed was pretty large. And in the video, I made it look like they asked ChatGPT, then they did a couple of tweaks and fixes, and then it started working. But in reality, I was asking and kept asking and getting errors and just rewriting it, and it didn't work. So eventually, I did it differently. I simply asked ChatGPT to write me the list of possible functions that I can apply and explain how those functions work and what kind of parameters they take. And then I use that to build the condition from the beginning. So from little pieces, I was writing a small parsing piece, checking the output, then connecting it to another piece, and so on and so forth, until I ended up with a final convoluted condition statement, which eventually worked. And then I had this thought that I could make a separate video about it. So that's why I will not go into detail here, because there's really a lot to cover and might be quite interesting, but maybe not for everybody. So I will keep it separate. And here I will just take a couple minutes to find that whole condition so that I can insert it here, because I really can't do this off the top of my head right now. Okay, there it is. I found it. Oh, there. But yeah, there you go. There. Let's make this big. Right. So that's a comment online. Let's delete this. Okay, let me see if this works. No. Yes, I found it. So here's the query. Here it works. We have all the correct overlapping date ranges as a result from it. And this is what it looks like from here until there. That's the condition that consists of two parts. In one, we're checking that first, this is the part that parses from text to date. This is the function date, and then this is what that function takes as arguments. Then it understands what date it is, and then compares it to this one. And then here's the second part, where again we have the function date, which takes all of this in order to read that non-ISO text and understand it as a date, and then compares it to this date. Definitely deserves a separate video. So let's move on to the last topic, which was dealing with data that's not in the database. And in our story, data is in a, we're still dealing with the dates here. So in the story, data that we need is somewhere in one of the many text files that we have on the computer. And the way we search through those files is using so-called grep search. In reality, however, data is in all kinds of files and in all kinds of different formats, and it's part of a job of the data people to deal with those formats, and there's a lot. This is a big topic, but right now I'll just show a little bit of this grep search, just to take the mystery out of it, at least a little bit. So let me adjust the scene and get to this point. All right, so I found a folder with the incident log. I will copy it right in here. So see, folder incident log and a bunch of files in there. So to go and do something in that file, first of all, we need to leave SQLite because that's no longer SQL. We do it by typing exit, and let's see, here is our folder that we need. We go into that folder like this, change directory, incident log, autocomplete there, and now we're there, and that's the list of all files, ls list. And what we're looking for is somewhere in those files. First, let me type up the whole thing and show you that it works, and then I will explain it bit by bit. Command find, unsurprisingly, dot minus name, star, in quotes, professor is what we're looking for. We're looking for that name. And here's our output. So we were looking for this name, professor, in all of the files in that directory. And if this name was found in a file, we printed out the name of that file here. So this is our output. That's actually a very good opportunity to use AI in one of the best ways that it can be used. So instead of letting it do everything for you, you can use it to explain everything to the detail and in depth. So let's try something actually that I haven't done before. Let's ask it to explain this command. So I will ask Grok. This time I just started using it, so let's see what it says. Please explain this here. Let me place it there for you. And there you go. Read and enjoy. Everything taken apart into small pieces. How it all works together and what it does, and examples. Nice, nice. So now we can conclude here. That's enough for today. We covered these three difficulties that you get to run into as soon as you start dealing with data. We dealt with it by not using anything that would need separate installing, with the only exception of this terminal that looks different, but that's just for aesthetics purposes. But you can use just your normal terminal instead of this. Everything would be exactly the same. So the point is that we dealt with this using absolutely nothing special, and in fact using tools that are considered to be difficult. A SQLite, terminal, only built-in tools. We didn't even have any tool to look up the database, and everything could be done fairly quickly and fairly easily, as you can see here. Okay, grep search, never mind, but that's not even SQL. My point is, if you can do it with tools like this, then you can definitely deal with these problems when you have more advanced tools. And further on, we are going to go on to some more advanced tools. I'm very much looking forward to it. So, see you later.